Example, we're going to use a determinant to find the area of a parallelogram. So we want to know the area of a parallelogram with a vertex. So one vertex of my parallelogram is going to be at 5, 7, and the other one is at 2, -5. All right, so I'm going to grab my graph this time. And I'm going to graph this guy. So I think I'm going to move it over to the edge here. Rotate it. Move this up. I want to be a little bit accurate here. All right, so this first one is 5, 7. So each of these is one unit. So 5, 1, 2, 3, 4, 5, 6, 7. And then the other one is 2 and 5. 1, 2, and -5. 1, 2, 3, 4. All right, so let's get our motion here by drawing our lines to these points. And what I'm going to do is I'm going to create a parallelogram off of this. So this is 5 down. 1, 2, 3, 4, 5. We'll end it. This is not exactly the right parallelogram. 1, 2, 3, 4, 5. So it ends there. Go here. Try to get this one again. That length. Or the angle, and create my parallelogram here. Alright, so there's my parallelogram. What we want to find is the area. Our parallelogram could actually be seen as two triangles. Divide this in half so you could see the two triangles a little bit better. So we have triangle 1 here. We have triangle 1 here. Then we have triangle 2 here. So 2 triangles in this. And we already know the formula for a triangle. So we know that this is going to be, we've seen this before, is 1/2 determinant t. So in our case of the parallelogram, we have 2 of them. So this is going to be 2 times this. 2 times that, which is going to keep us, and I'm going to say P for parallelogram, so P equals 2t, and this is going to equal the determinant of P. Or sorry, the determinant of T. I went too far. Alright, so now looking at this, I need to come up with my matrix T. So T is going to equal, if I remember this correctly, we're going to do the x's, so 5 and 2 in the upper row, and then the y's, 7, -5 in the lower rows. So we're looking at the determinant of t is going to equal -25 -25 minus, and because this is a length, this is actually absolute value, so let's add those in there. -25 minus 7 times 2, because the area is going to be positive in our case, and this is equal to 39. And remember, area is positive. We can have negative area, but when we're looking at this, we're kind of looking at what our area of the parallelogram is, how much space does this take up no matter what quadrant we're in. So the area of the parallelogram is 39. Alright, so let's try this again. Let's look at another parallelogram. This time I'm not going to graph it out. We're just going to look at it. So let's say I have a parallelogram from -2 to 1 and then 1 to A. And it has an area of 5 square units. So what is my possible values of a's? Well, I know that t now is going to equal my x's, -2 and 1, 1 and a. And I know that the det, the absolute value of my determinant, is -2a minus 1 is going to be equal to 5. So solving for a, we get, what is that, -2a equals 6. Divide by -2, a equals -3. But remember, this is the absolute value. So this is only one solution. The second solution is going to be 2a plus 1 equals 5. So subtract 1 from each side. Equals 4. Equals 2. So the two possible solutions are a equals -3 and a equals 2. And again, the way I got the second one is because this is an absolute value. You're going to do -2a minus 1 and then positive 2a, -2a minus 1 equal to 5 to find the two solutions for this. All right, so the next thing for us to do is basically just check. We just substitute these numbers into our equation here. We do find that both do equal 5, so two of our possible values are -3 and 2 for this parallelogram. All right, guys, so that's the end of this example. If you have any questions, always feel free to ask, and I'll catch you in the next video.